All right, here we are at the last video, and you know, I gotta say, because I know you were thinking it, I know you were thinking, oh, just 2 pages front and back, and yet somehow we made 4 videos out of it. And that's kind of the nature of as you get into higher math classes. The shorter the amount of pages, the more afraid you should be of what you have to do on those pages. So sorry, but here we go. So, the good news is we get to review all of it on these last two. Anyways, let's dive in. So, what are we talking about with these rational functions, and how do we bridge the gap of all that we've looked at and actually looking at the graph? And do these have regular transformations? And the answer is yes, we'll see that as well. So, here we go. The most basic rational function is 1 over x. In order to be a rational function, you need to be a fraction. You need to have algebra in the bottom. What's the simplest fraction you can have with algebra in the bottom? 1 over x. So there we go. Now, how do I graph this thing? Well, we've got a lot to discuss. This graph has a vertical asymptote because there is algebra on the bottom that doesn't cancel at 0. This graph has a horizontal asymptote, as we just learned in the last video. Your numerator's algebra's exponent is 0 because there is no x. Your bottom algebra is 1, so 0 in the numerator, no x's on top, versus 1x on the bottom, is going to put you in the HA y equals 0 category. So essentially, your x and y axis are your asymptotes that you won't cross. From there, what do we do from there? Honestly, the answer is you plug in test points, which is not glamorous, but here we go. What do I mean? If I plug +1 into this, what do I get? So, in other words, if I build a table here, I'll do it on the left. If I let x equals 1, then I actually get 1. So I'm going to plot that. Now, then you sit there and go, oh, let me plug in 0. Well, if you plug in 0, you're on your vertical asymptote, so that doesn't work, unfortunately. But then what do you do? Why don't you try plugging in 2, but you get 1/2. So 2 1/2, you can graph that. It's actually right there. You could plug in 3 and get a third. You could plug in 4 and get a fourth. You could plug in 5 and get a fifth. But peculiarly, if you think about that, you could plug in 100 and you still wouldn't be 0. You'd be 1 over 100. And hopefully there, you get the idea that that's what's forming that horizontal asymptote along y equals 0. You'll always hover over 0. You'll be 1 over 100, 1 over 1,000, 1 over a million, 1 over a billion. But guess what? 1 over a billion is still never 0. It's always hovering above y equals 0. Now, what happens the other way? We don't really have time to talk about this, but if you were to plug in 1/2 into this, take your calculator and carefully type 1 divided by parentheses 1/2, and you'll actually get 2 out of it. And if you don't, try again until you do. And guess what you get? You end up getting some symmetry here. So that is what you're going to get if you kind of follow that behavior. If you plug in 1/3, you get 3. If you plug in 1/4, you get 4, so on and so forth. Now, what do we get when we move into the negatives? If I plug in -1, then I get -1. So there's that from the origin. And trust me that as far as this basic graph, you end up getting symmetry. Here's a big key idea. You get symmetry with respect to the origin. This graph is a double flip away from being symmetrical. So this graph actually is considered odd in a sense, and it does have symmetry with respect to the origin. So already, take a look at this. We've talked about vertical asymptotes, horizontal asymptotes. We talked about even or odd. We evaluated functions by plugging stuff in, and now I see this behavior that has symmetry with respect to the origin. There is a lot going on here in just this parent graph. But after all of that clicks, guess what? Any parent graph can be shifted to the left, shifted to the right, moved up or down, stretched or compressed, all of those things. And so, in this one example, I want to ask you what is going on with this graph? And think back to your function transformations and think carefully about how we describe them. And hopefully, this isn't too bad. But this graph, well, let's do the easy one, moved up 3. Hopefully, we all know that because there's a big plus 3 at the end. But what also happened to this graph? This graph moved right 4. Now, why do I say that? And the answer is, well, because of how I told you about the transformations verbally in the past lectures. I said that for left or right, the question is, what were you adding or subtracting from the thing that gives the function its name? Catch that wording. What were you adding or subtracting inside or from the thing that gives the function its name? Well, the thing that gives a rational function its name is the fact that algebra is in the denominator. And so something is being subtracted from the algebra in the denominator. And we know that when it's adding or subtracting in the thing that gives it its name, we flip the sign, so to speak. And so positive 4. And so, with all that being said, I now know what this graph looks like from my parent graph. I've memorized this shape. Thankfully, we're not doing any flipping or compressing or stretching. But this graph, if I move it up 3 and right 4, what have I really done? Well, even though it's not a point on the graph, there still is this point right here in the origin, which is causing some symmetry. And what we're essentially saying is this symmetry point, this very special point in the middle, has moved up 3 and right 4. We'll draw a little point here, and now I'm going to draw my asymptotes, because that's essentially what we are saying is happening here. Now, real quick, if you're saying, Mr. Rao, wait a minute, based on your HA rules you told me, wouldn't this be an HA of 0? And whoa, just to catch you there. The way we defined determining HA is when your problem looks like one polynomial on top, one polynomial on bottom. There can be multiple terms, but there's no addition or subtraction here. So just to say that out loud, we're not going to work out because we don't need to worry about it, but there is a way to make common denominators and put these together, and then you would see your HA being at positive 3. All right. But anyways, from there, what is going on here? Well, here's my special invisible point, and there was a perfect diagonal up one, right one. There was a perfect diagonal down one, left one. And so this must be the translated graph. All right. So it's not a perfect work of art. This should technically not be going away from. I just, as a math teacher, I'm very cautious of accidentally crossing, because I'd rather drift away accidentally in my drawing than cross over accidentally, because I know for a fact that these are asymptote lines, and I know I will never cross, but hopefully that looks a little bit better. So there we go. We can take these graphs, and again, move up or down, left or right, and we won't do more than that, because otherwise it gets pretty ugly. Now we get to these last two questions, and we're going to go fairly quick, but we get to revisit everything we've just done now in 2 questions. So first, this graph. Let's think all the way back to the beginning of this section. Does this graph have a domain? Yes, it does. This graph's domain is, think about it, anything that's not x equals 5. Or in other words, there's your domain. Anything except for 5. Now then the question is, do we have any holes? Is there algebra that perfectly cancels on the top and bottom? No. So there's no holes. What about vertical asymptotes? Do we have vertical asymptotes? Is there algebra that causes 0 on the bottom that isn't going away? Yes. And that's why our domain was split. So our vertical asymptote is x equals 5. Now, is there a horizontal asymptote? Compare those exponents. We're back to one fraction over one fraction, so we're good to, again, find the HA. Well, guess what? Your numerator has a highest exponent of 1. Your denominator has a highest exponent of 1. They match, and so your HA is the coefficient 3 over the coefficient 1, which is just 3. Now, what they then ask you to do on your homework, I will just say, is they ask you to draw some test points, but here's what I'm going to do. I'm going to draw a basic graph. Thankfully, you're still using your graphing tool, but I'm going to draw my vertical asymptote through x equals positive 5. I'm going to draw my horizontal asymptote, I guess, respectively, through y equals 3. And then I'm going to ask myself, what does this graph do? And so maybe I'll use some test points, and I'm not going to do too many, but if I've got this x equals 5 and this y equals 3, what could I plug in? Now I think this is what I've tried to say 3 different ways, but didn't say it right. What your homework does is it tells you what to plug in for you. But what I used to do is I used to tell my students, well, find your vertical asymptotes and plug in stuff right around it. So let's try plugging in 6. If we plug in 6, now I'm going to do this mentally, but that's going to end up being 18 over 1, which is of course 18. So that's pretty large. Let's try 7. If I do 7, that's going to be 21 over 2. I don't like that because that's a fraction. Let's try 8. That'll be 24 over 3. Ooh, I like plugging in 8 because plugging in 8 gives me 24 over 3, and 24 over 3 is 6. So that's finally something I can graph. So if I move over 3 units over to 8, I end up getting 6. Interesting. What about, let's see here. Let's find something on the negative end. Or you know what? Honestly, no, let's not. Let's just stop it there because I trust that through your homework you'll plug stuff in. Here's what I want you to know. That evidently if I went right 3 to get an answer, and careful how I'm saying this, sorry. If I went right 3 from my vertical asymptote to get a valid answer, let's go left 3 to get a valid answer. But here's what I can already tell you. I can already tell you that the answer is going to be somewhere right here. I think it's going to be actually here. What would that be? I think it's going to end up being 2, 1. I haven't done the math. Let me tell you why I know that that's probably the answer, though. Because, or maybe it's 2, 2. I gotta think about it. But it's because I know that there's symmetry. So if I found this one that, again, notice it wasn't perfectly on the diagonal, but if this one's, symmetry line closer to the, like farther to the right and a little bit up, then this one should be farther to the left and a little bit down. They're symmetrical. So anyways, let's go 3 to the left. Let's plug in 2 now. If I plug in 2, that's 6 over negative 3, which is, wait a minute, sorry, I'm just checking. 6, yeah, over negative 3, which is negative 2. So my scaling was definitely off. That's fine. There we go. So this graph must look like this. All right. So why does that scaling look bad? All right. Well, I plugged it in and it looks fine. So I don't know what I was worried about. Oh, you know what? Here's why the scaling's bad. Because I drew it bad. Here's what I mean by that. The way I drew mine compared to the graph now that I'm looking at it, here's 8. 8 was still kind of on that like major downward curve. So I'd kind of just, again, scaled it oddly. But whatever, we're not drawing these by hand, we're using the graphing tool. So with that being said, let me try to fix that and make it look a little better. Maybe that looks better. But ultimately, it doesn't need to be a work of art. It just needs to cross through everything and be good to go. So I had the points right. Again, drawing by hand, these are not fun. You never will also, so don't worry about it. All right, let's look at number 2, and let's go through the same process again. First, let's look at my algebra. And so here's the other thing is, even though this is my algebra and we've got all these questions, really the first thing is, can you factor some of your algebra? The answer is yes, because for the last time today, or whenever you're watching this, we have a difference of squares again. And so I now know that my domain is I just can't be -3 in order, and then I can't be +3. That's what I mean by order, but then I can be anything else. All right, so we're cutting to 2 pieces there. Um, from there, are there any holes on this graph? No. And like I said, we won't need to worry about holes graphing wise, but we wanted to talk about them. From there, are there any vertical asymptotes? So are there anything in my denominator left over that didn't cancel? Well, yes, the thing that caused the breaks in my domains. -3, not domains, domain. But there were 2, that's why I said plural. So the 2 items that caused breaks in my domain are -3 and 3. Um, there we go, in order. From there, what's my HA? Compare exponents. What's your top exponent? 1. What's your bottom exponent? 2. Top is less than bottom. HA 0. So I hope you see that all of these ideas are coming into play. Now we plugged in some test points before here. I want to show you one other interesting test point that they'll throw at you. And that is the test point plug in 0 for x. And that would of course be the y-intercept. So in fact, you can see the irony is, and in fact I'm kind of shocked by this, on this last example, I just drew this graph and ended up scrolling my pencil across the perfect x equals 0, 0, and I was actually right. So I had a little intuitive sense. Again, I just kind of messed up on the scaling on that part, but whatever, I'm not going to beat myself up over it anymore. Anyways, from there, sometimes they will ask you to plug in 0 to find the y-intercept, and well, you just plug in 0 and see what you get, and it might be an ugly fraction, but that's okay. Anyways, what does this graph look like? Now this one's going to be worse to diagnose, but thankfully, if you have looked at your homework, you end up doing these as multiple choice. So here's -3, here's +3, and I know there's a horizontal asymptote at 0. If I plug in 0, actually, if you work this out, that's going to end up being 0 over -9. And guess what? 0 over -9 is still just 0. Interesting. If we plug in a few more test points, we actually have kind of a lot to do here. Here's why we have a lot to do, or why you'll do a lot in your homework, because your domain is split into 3 sections. And so just having one point in my first section doesn't tell me if my graph looks like this, if it looks like this, if it looks like this, if it looks like what we saw in our this example. Like, not only is it broken into 3 pieces, but do the 3 pieces look completely disjointed and ugly from one another with no symmetry in their own parts? Or do they look almost symmetric with a funky middle, right? Hopefully you kind of see that there's a lot of different ways your graph would or could look when it's cut into 3 separate pieces. There's some inherent symmetry going on here, or each one is its own thing, and even this piece in the middle doesn't have any symmetry to it in its own middle section itself, like compared to this one, if you kind of see what I'm saying there. So every graph can be different. So we need a lot of test points to determine, as you'll see in your homework. Now I'm going to call these out and just try them. But of course, I'm always going to try 1. And what that's telling me is right here. I'm still in my middle piece. If I plug in 1, that's going to be 2 over -8, which is, let's see here, 2 over -8 is -1/4. So great, I plugged in 1, and I got -1/4. And guess what? If I plug in -1, for similar reasons, I'm going to actually end up with +1/4. And so I'm pretty confident then that this section looks like this. And if you're wondering, well, Mr. Ra, how are you going through that so quickly? Well, it's because, after all I'm doing there is saying I know asymptotes are supposed to be like hugged against or approached. So once I get that little kind of diagonal shape, I know from the diagonal shape, I'm going to swoop towards my asymptotes and hug around them. And we'll check the graph later. Now, from there, what I need to do is I need to check what's going on after my asymptote. What goes on after, I guess we'll go positives first. What goes on after 3? Well, 4. So let's try plugging in 4. Plugging in 4 would be 8, oh gosh, over 16 minus 9, which, so think about that. That would be 8 over 7. I mean, I'll write 8 over 7, but that's a little bit more than 1. So there we are. What if I plug in 5, just to get a better sense? Plugging in 5 will give me 10 over, let's see here, 10 over 25 minus 9 is 16. 10 over 16. Here's what I know about 10 over 16. 10 over 16 is, uh, let's see here. Now I gotta think about it. 10 over 16 is closer, uh, sorry. Yeah, I don't know why I was overthinking that for a second. 8 over 7 is more than 1. 10 over 16 is less than 1. I'm getting closer to 0. So that gives me a pretty confident bet that I'm approaching this. Now also, why do I know for a fact I'm approaching this? Because a vertical asymptote is going to have some sort of shape like that if it's above. Also, I've got a horizontal asymptote at 0, so I know I should be approaching the x-axis, but never crossing it, because that's y equals 0 is the x-axis, so I'm hugging towards that. Now, the very last question is essentially, if you're kind of following, does the last section look like this, or does it look like this? And, well, guess what? We're going to plug in a test point. But this test point needs to be further left than -3. If I plug that in, I don't know, -4, to be super inventive, that would be -8 over, actually, again, +7. -8 over 7. And so that's my confirmation that, and you can see how lazily I wrote that, because again, it's a graphing tool that you're going to be using. My graph must look something, now I want to make them look symmetrical and sloppy. Must look something like this. Great. And now we're going to confirm that by looking at Desmos. If I have 2x over x squared minus 9, there is that graph. So there's the perfect y-intercept at 0, 0. There are my vertical asymptotes at +3, whoops, and hello, -3. There's my horizontal asymptote at 0, and there's that middle section that started up top and then went down, and then there's my right section that started positive and stayed positive and hugged 0, and then here's my left section that was negative and stayed negative and hugged 0. So all of that baked in, and we just discussed everything from top to bottom. So hopefully that was kind of nice to see it all in one example. I know it's daunting, but we did the domain, we talked about holes, we did vertical asymptotes, we did horizontal asymptotes, we plugged stuff in and did some algebra, we practiced our factoring. Wow. So good luck with this section. I know the concepts can be a little bit confusing and balancing them all out and learning all those rules, but that's why you can always email me and message me if you're having trouble, and I'll see you next week.